Foundations of Amateur Radio. Amateur radio is a living anachronism. We have this heady mix of ancient and bleeding edge, never more evident than in a digital mode called Automatic Packet Reporting System, or APRS. It's an amateur mode that's used all over the place to exchange messages like GPS coordinates, radio balloon and vehicle tracking data, battery voltages, weather station telemetry, text, bulletins, and increasingly other information as part of the expanding universe of the Internet of Things. There are mechanisms for message priority, point-to-point messages, announcements, and when Internet-connected computers are involved, solutions for mapping, email, and other integrations. The International Space Station has an APRS repeater on board. You'll also find disaster management like firefighting, earthquake, and propagation reporting uses for APRS. There's tools like an SMS gateway that allows you to send an SMS via APRS if you're out of mobile range. There's software around that allows you to post to Twitter from APRS. You can even generate APRS packets using your mobile phone. In my radio travels, I'd come across the aprs.fi website many times. It's a place that shows you various devices on the APRS network. You can see vehicles as they move around, radio repeater information, weather, even historic charts of messages, so you can see temperatures over time, or battery voltage, or solar power generation, or whatever the specific APRS device is sending. As part of my exploration into all things new and exciting, I thought I'd start a new adventure with attempting to listen to the APRS repeater on the International Space Station. I'm interested in decoding APRS packets, seeing what's inside them, and what kinds of messages I can hear in my shack. Specifically for the experiment at hand, I wanted to hear what the ISS had to say. After testing some recommended tools and after considerable time hunting, I stumbled on Multimon NG. I should mention that it started life as Multimon by Tom, Hotel Bravo 9 Juliet November X-Ray, which he wrote in 1996. In 2012, Elias Onal wanted to use Multimon to decode from his new RTL SDR dongle, and in the end he patched and brought the code into this century, and Multimon NG was born. It's available on Linux, macOS, and Windows, and it's under active development. It's a single command line tool that takes an audio input and produces a text output, and it's a great way to see what's happening under the hood, which is precisely what I want when I'm attempting to learn something new. In this case, my computer was already configured with a radio. I can record what the radio receives from the computer microphone, and I can play audio to the radio via the computer speaker. My magical tool, Multimon NG, has the ability to record audio and decode it using a whole raft of inbuilt decoders. For my test, I wanted to use the APRS decoder, cunningly disguised as an AFSK 1200 demodulator. I'll get to that in a moment. The actual process is as simple as tuning your radio in FM mode to the local APRS frequency and telling Multimon NG to listen. Every minute or so you'll see an APRS packet, or 6, turn up on your screen. The process for the ISS is only slightly different in that the APRS frequency is affected by Doppler shift, so I use gpredict to change the frequency as required. Multimon NG continued to happily decode the audio signal. I said that I'd get back to AFSK 1200. The 1200 represents the speed, 1200 baud. The AFSK represents audio frequency shift keying, and it's a way to encode digital information by changing the frequency of an audio signal. One way to think of that is having two different tones, one representing a binary 0, the other representing a binary 1. Play them over a loudspeaker and you have AFSK. Do that at 1200 baud and you have AFSK 1200. When you do listen to AFSK and you know what a dial-up modem sounds like, it will come as no surprise that they use the same technique to encode digital information. Might have to dig up an old dial-up modem and hook it up to my radio one of these days. Speaking of ancient, the hero of our story, APRS, dates back to the early days of microcomputers, the era of the first two computers in my life, the Apple II and the Commodore VIC-20. Bob, Whiskey Bravo 4 Alpha Papa Romeo, implemented the first ancestor of APRS on an Apple II in 1982. Then, in 1984, he used a VIC-20 to report the position and status of horses in a 160-kilometre radius using APRS. As for the International Space Station, the APRS repeater is currently switched off in favour of the crossband voice repeater, so I'll have to wait a little longer to decode something from space. I'm Onno, Victor Kilo 6 Foxtrot Lima Alpha Bravo.